Welcome to phase 5 of our series, The Future of LLMs. Today we're discussing ethical and societal considerations around large language models.
These technologies are powerful, and with power comes responsibility. Understanding the ethical implications is crucial.
Let's start with bias. We've mentioned it before, but let's go deeper. How does bias manifest in LLMs?
LLMs learn from human generated text, which reflects historical and societal biases around gender, race, age, disability, and other attributes.
The models can perpetuate stereotypes associating certain professions with particular genders or certain characteristics with ethnic groups.
They might generate lower quality outputs when prompted with names or contexts associated with marginalized groups.
Or produce content that reinforces harmful stereotypes, even if not explicitly hateful.
Measuring bias is challenging because it's multifaceted and context dependent.
Benchmarks like We Know Bias, Stereoset, and Bold attempt to quantify different dimensions of bias.
But passing these benchmarks doesn't guarantee absence of bias in real world use.
Mitigating bias is even harder. You can curate training data to reduce biased content,
You can use fine tuning or RLHF to reduce biased outputs.
or apply post processing filters to catch and modify problematic generations.
But these approaches have limitations. Overly aggressive debiasing might reduce model usefulness.
And bias is often subtle. The absence of certain perspectives can itself be a form of bias.
Let's talk about fairness. What does it mean for an LLM to be fair?
Fairness might mean equal performance across demographic groups,
Or it might mean that outputs don't discriminate based on protected attributes.
but fairness is context dependent. Different applications might require different fairness criteria.
And there can be tensions between different notions of fairness.
For example, treating everyone identically might perpetuate existing inequalities, while differentiated treatment might feel discriminatory.
Now let's discuss privacy. How do LLMs impact privacy?
Training data might contain personal information that the model memorizes.
Models can sometimes regurgitate training examples, potentially exposing private information.
This is especially concerning for models trained on web data, emails, or other sources that might contain PII.
Techniques like differential privacy add noise during training to reduce memorization.
But this can hurt model quality, creating a privacy utility trade off.
Another privacy concern is prompt injection attacks,
Malicious users might craft prompts to extract information about other users or the training data.
or to manipulate the model into revealing system prompts or bypassing restrictions.
Defending against these attacks is an ongoing challenge.
Let's talk about misinformation and disinformation.
LLMs can generate convincing but false information at scale.
This could be used to create fake news, manipulate public opinion, or spread conspiracy theories.
The models don't have intent, but bad actors can use them with malicious intent.
Watermarking generated text is one potential mitigation,
Statistical watermarks embed patterns that can identify AI generated content.
but adversaries can potentially remove or evade watermarks.
Provenance tracking, labeling AI generated content, is another approach.
But it requires cooperation from generators and platforms.
Media literacy, helping people critically evaluate information, is also crucial.
Now let's discuss labor and economic impacts.
LLMs are automating tasks that previously required human cognitive work.
This could displace workers in writing, translation, customer service, and other fields.
Or it could augment workers, making them more productive.
The actual impact depends on how the technology is deployed and how society responds.
There's also the hidden labor in AI, data annotators, content moderators, and others who enable these systems.
Much of this work is outsourced to low wage workers in developing countries.
Working conditions, fair compensation, and psychological support for this workforce are important ethical considerations.
Let's talk about environmental impact.
Training large models consumes enormous amounts of energy.
This translates to carbon emissions contributing to climate change.
The environmental cost depends on the energy source. Renewable energy is better than fossil fuels.
Inference also has environmental impact, especially at scale.
Efficiency improvements, better algorithms, hardware, and training techniques can reduce environmental footprint.
But the overall trend is toward larger models and more applications, potentially increasing total impact.
There's a question of whether the benefits of these models justify their environmental costs.
And how to balance innovation with sustainability.
Now let's discuss accountability. When an LLM causes harm, who's responsible?
Is it the model developers, the deployers, the users, or the model itself?
Current frameworks hold humans accountable, not AI systems.
But attribution of responsibility is complex in multi party AI systems.
Clear documentation, model cards, and system cards help establish what models can and can't do.
Audit trails and logging help trace problematic outputs to their source.
But legal and regulatory frameworks are still evolving.
Let's talk about consent and data rights.
Much training data is scraped from the internet without explicit consent from creators.
This raises questions about whether this use is ethical or legal.
Some creators have opted out or requested their data be removed from training sets.
But enforcement is challenging, and the data may have already been used.
There are ongoing legal cases about copyright and fair use of training data.
The outcomes will shape future data practices.
What about dual use concerns?
LLMs can be used for both beneficial and harmful purposes.
The same model that helps with education could be used to generate spam or scams.
This is particularly acute for capabilities like code generation, which could aid both developers and cybercriminals.
Managing dual use risks requires balancing openness with security.
Some propose staged release, gradually expanding access as safety is validated.
Others favor open release with monitoring and response capabilities.
Let's discuss representation and diversity.
Who gets to shape these powerful technologies?
The AI field lacks diversity in terms of gender, race, geography, and perspective.
This can lead to technologies that work better for some groups than others.
Or that embed particular cultural assumptions.
Increasing diversity in AI research and development is crucial.
As is including diverse voices in governance and policy decisions.
What about accessibility?
LLMs could make technology more accessible through natural language interfaces.
They could help people with disabilities or those less technically skilled.
But access to the most capable models is often limited by cost or geography.
This creates digital divides where some benefit more than others.
Ensuring equitable access is an important societal goal.
Finally, let's talk about alignment with human values.
How do we ensure LLMs behave in ways that reflect human values and intentions?
This is challenging because values differ across cultures, individuals, and contexts.
There's no single correct way for models to behave in all situations.
RLHF and constitutional AI are attempts to instill values during training.
But they reflect the values of those providing feedback or writing constitutions.
Ongoing dialogue between technologists, ethicists, policymakers, and the public is essential.
So, to recap, LLMs raise ethical issues around bias, fairness, privacy, misinformation, labor impacts, environmental sustainability, accountability, consent, dual use risks, diversity, accessibility, and value alignment. Addressing these requires technical solutions, policy frameworks, and societal choices, and the field is actively grappling with these challenges as technology advances.